Hello everyone, I'm Teacher Michelle and welcome to another episode here in Unang Math. This is episode 49 and for this episode, our lesson is still about prime factorization. And this is part 3 of this topic. In the previous episode or episode 48, we already studied the use of prime factorization, and that is prime factorization is used to find all the factors of a number. In this episode, we will study how to find the greatest common factor of numbers using prime factorization. This episode is divided into two parts. In the first part, I will discuss the property of greatest common factor or GCF and coprime. We already studied greatest common factor in episode 2, but we need to repeat the property of greatest common factor because this is very important in our lesson this episode. Also, I will discuss this new word, coprime. In the second part of this episode, we will find the greatest common factor of numbers using division method and prime factorization method. In division method, we will use this if the given numbers are small numbers and the given numbers are just 2 or 3 numbers. But we will use prime factorization method if the given numbers are large numbers and the given numbers are 3 or more numbers. Let's start with the property of greatest common factor or GCF and coprime. We already studied greatest common factor, so this will just be a brief review. And for the rest of the lecture, I'll just be using the acronym GCF. To find the GCF of numbers, first, we have to know the common factors. When we say common factors, these are factors that are common to numbers. To find the common factors, we have to know the numbers factors. Okay, example, what are the factors of 8 and 12? To find the factors of a number, we can use multiplication or division. In multiplication, just think of two numbers that when multiplied together, the answer is the number. In division, we just need to think of a number that evenly divides the number. Okay, what are the factors of 8? We have 1 and 8. 2 and 4 are also factors of 8. How about 12? We have 1 and 12. Okay, 2 and 6 are also factors of 12. 3 and 4 are also factors of 12. Among these factors, what are common factors? Okay, let's see. 1 is a common factor. 2 is also a common factor. And 4 is also a common factor. So we have 1, 2, and 4, and these are the common factors of 8 and 12. Among these common factors, which one is the highest? 4 is the highest number, so it means 4 is the GCF of 8 and 12. So what is the property of GCF? The common factors of two or more natural numbers are all factors of their GCF. Let's explain this sentence by looking back at our example a while back. Okay, what is the GCF of 8 and 12? Okay, we got 4 a while ago. Okay, according to the property of GCF, the common factors of two or more natural numbers are all factors of their GCF. Okay, let's get all the factors of 4. We have 1 and 4. Okay, 2 is also a factor of 4. It means 1, 2, and 4, these are common factors of 8 and 12. Property of GCF is very important because in exams or in tests, even if they didn't give the numbers, as long as we know the GCF, then we can find the common factors of the numbers. Okay, example. The GCF of two natural numbers, A and B, is 36. Which of the following is not a common factor of A and B? We actually don't know what are the numbers or what are these numbers A and B, but we know that the GCF is 36. So using the property of GCF, we can find or we can know all the common factors of A and B. Okay, let's get all the factors of 36. We have 1 and 36. What else? 2 and 18. 3 and 12. Okay, 4 and 9. 6 is also a factor of 36. So in these choices, 5 is not a common factor of A and B because we cannot find 5 in these listed factors of 36. Okay, let's move on to co-prime. Numbers are co-prime when the only common factor is 1. Okay, example. We have 7 and 13. 7 and 13 are prime numbers. We all know that prime numbers factors are only 1 and the number itself. It means 7 and 13 common factor is 1. So 7 and 13 are co-prime. Another example, 6 and 8. 6 and 8 can be divided into 2. Both can be divided into 2. It means, aside from 1, 2 is also a common factor of 6 and 8. So it means 6 and 8 are not co-prime. Okay, this time, let's answer the following statements by saying if it's true or false. Okay, the first statement is, two distinct prime numbers are always co-prime. Okay, the answer to this statement is, okay, true. Because prime numbers, only factors are 1 and itself. So two prime numbers, common factor is only 1. So this statement is true. Okay, how about the second statement? Two co-prime numbers are both prime numbers. Okay, this statement is false. Let's give an example. Number 14 and 15. What are the factors of 14? We have 1 and 14. Okay, 2 and 7. How about 15? We have 1 and 15. 3 and 5 are also factors of 15. Okay, the only common factor of 14 and 15 is 1. Okay, but 14 and 15 are not prime numbers. That's why this statement is false. Okay, let's move on to the third statement. 1 is a co-prime of any number. Okay, this statement is true because 1 has only one factor, and that is 1. Okay, fourth statement. Two different odd numbers are co-prime. This statement is false. Example, 3 is an odd number. 9 is also an odd number. What are the factors of 3? We have 1 and 3. How about 9? We have 1 and 9, and 3 is also a factor of 9. Okay, aside from 1, 3 is also a common factor of 3 and 9. So this statement is false. Okay, let's move on to the last statement. Is it true or false? In irreducible fractions, the denominator and numerator are co-prime. When we say irreducible fractions, these fractions are already in its lowest terms. And we all know that if a fraction is in its lowest term, the only common factor is 1, or the only common factor of numerator and denominator is 1. So this statement is true. Okay, let's answer this problem or another problem. Which of the following two numbers are co-prime? In this kind of problem, it's difficult and it will be long if we are going to list or write all the factors of each number. So our strategy here is we just need to think of a number that we can divide to both numbers. Okay, let's have the first pair of numbers, 3 and 15. We can divide 3 and 15 both by 3. So it means, aside from 1, 3 is also a common factor of 3 and 15. So 3 and 15, these are not co-prime numbers. Okay, how about B, 35 and 63? We can divide both numbers by 7. So it means, aside from 1, 7 is also a common factor of 35 and 63. So 35 and 63 are not co-prime. Okay, let's go to the third pair, 27 and 81. Okay, we can divide both numbers by 9. So it means, aside from 1, 9 is also a common factor. So these are not co-prime. Okay, how about D, 26 and 65? We cannot think of a common number that we can divide to both numbers, so we will solve it manually. So 26 divided by 2, 13. How about 65? 65 divided by 5. The answer is 13. So it means, aside from 1, 13 is also a common factor of 26 and 65. So D is not co-prime. Let's go to E, 22 and 111. Okay, 22 divided by 2, 11. 111 divided by 3 is 37. Okay, it means 1 is the only common factor of 22 and 111. So E, this pair of numbers are co-prime numbers. So the answer is E. We are now in the second part of this episode, and this is about finding the GCF of numbers. There are two ways on how to find the GCF of numbers. We can use division method or prime factorization method. Let's start with division method. To use division method, we will follow these 3 steps. Let's give an example. Let's find the GCF of 12 and 18 using division method. First step, we will divide each number by the common factor other than 1. 12 and 18's common factor is 2. So let's divide. 12 divided by 2 is 6. 18 divided by 2 is 9. Second step, continue dividing until the quotient has no common factor other than 1. 6 and 9 has common factor 3. So let's continue dividing. 6 divided by 3 is 2. 9 divided by 3 is 3. This time, 2 and 3 have no more common factor other than 1. Third step, we will multiply all the common factors. So what are the common factors? 2 and 3. So 2 times 3, the answer is 6. 6 is the GCF of 12 and 18. Okay, when we use division method, or division method is used when the numbers or the given numbers are small numbers and the given numbers are 2 or 3 numbers. Let's move on to the second method. Okay, this time we will use prime factorization to find the GCF of numbers. To use prime factorization, okay, we will follow these 3 steps. Let's give an example. Let's use the same numbers, 12 and 18, but this time, we will find 12 and 18's GCF using prime factorization. First step, we need to factorize each number into its prime factors. It means we need to find 12 and 18's prime factorization. Okay, 12 is equal to 2 times 6. And 6 is 2 times 3. So 12's prime factorization is 2 times 2 times 3. And this is equal to, okay, 2 squared times 3. How about 18? 18 is equal to 2 times 9. And 9 is equal to 3 squared. Okay, second step. Among powers with the same base, find the one with the same or smaller exponent. Okay, it means we need to write the prime factorizations of the numbers, okay, by aligning those with the same base and finding the one with the same or smaller exponent. 2 squared and 2 have the same base 2, and these two numbers are aligned. 3 and 3 squared have the same base 3, and these numbers are also aligned. Okay, now let's find the one with the same or smaller exponent. 2 is smaller than 2 squared, so we will get 2. 3 is smaller than 3 squared, so we will get 3. Okay, why do we need to get the same or smaller exponent? Okay, 2 squared factors are 1, 2, and 2 squared. Okay, how about 2? 2's factors are 1 and 2. Okay, what are the factors or common factors of 2 squared and 2? We have 1 and 2. 2 squared or 4 is not a common factor of 2 squared and 2. So we need to get the smaller number or the same number. Okay, third step, multiply all the numbers obtained in number 2. So 2 times 3, the answer is 6. Okay, 6 is the GCF of 12 and 18, and that is using prime factorization method. Okay, prime factorization is used if the given numbers are large numbers and if the given numbers are 3 or more numbers. Let's have another example. This time, let's find the GCF of 20 and 30 using prime factorization. Okay, first, we need to find 20 and 30's prime factorization. Okay, 20 is equal to 2 times 10, and 10 is equal to 2 times 5. So 20's prime factorization is 2 times 2 times 5, or 2 squared, okay, times 5. How about 30? 30 is equal to 3, okay, times 10. And 10 is equal to 2 times 5. So 30's prime factorization is 3 times 2 times 5. Or let's arrange these numbers from smallest to largest. So 2 times 3 times 5. Okay, now we need to write the prime factorization of these numbers by aligning those with the same base. 2 squared and 2 have the same base 2, and these numbers are aligned. Okay, 5 must be aligned to 5. So let's move this one here. So times 5. So these numbers are the same numbers. Okay, how about number here? Okay, we can think that the number here is 1. Okay, so let's find which among these numbers are smaller. 2 squared and 2. Smaller is 2, so we will get 2. How about here? Same numbers, so we just need to copy the number. Okay, here, 1 and 3. Okay, smaller number is 1. Okay, but 1, or when 1 is multiplied to a number, the answer is the number. So we can just, okay, remove 1. So 2 times 5, the answer is 10. So 10 is the GCF of 20 and 30. Okay, one more example. What is the GCF of 24, 96, and 132 using prime factorization? So we need to find 24, 96, and 132's prime factorization. Okay, let's start with 24. 24 divided by 2. Okay, this is 12. 12 divided by 2. 6. 6 divided by 2. 3. So 24's prime factorization is 2 raised to the power of 3. Okay, times 3. Okay, how about 96? Okay, what is 96 prime factorization? Let's find out. 96 divided by 2, this is 48. 48 divided by 2 is 24. Continue dividing. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2, 3. So 96 prime factorization is, okay, 2 raised to the power of 5 times 3. How about 132? Okay, what is 132's prime factorization? Okay, 132 divided by 2 is 66. 66 divided by 2 is 33. Okay, 33 divided by 3 is 11. So 132's prime factorization is 2 squared, okay, times 3 times 11. Okay, now we all know the prime factorization of each number. So we need to write the prime factorization by aligning those with the same base. So 2 raised to the power of 3, 2 raised to the power of 5, and 2 squared have the same base, 2. 3, these are the same numbers. So we will find, or we will get the smallest number. So among these numbers, 2 squared is the smallest. And these are the same numbers, so we will just copy or just get the same number. 2 squared is 4, so 4 times 3, the answer is 12. So 12 is the GCF of 24, 96, and 132. Okay, now, let's answer the following problems. Okay, the first problem is, which of the following is not a common factor of the numbers 2 raised to the power of 3 times 5 and 2 squared times 5 times 11. So this problem is asking for not a common factor of these numbers. Okay, so we get 2 raised to the power of 3 times 3, okay, times 5. Okay, and 2 squared, okay, times 5 times 11. So we need to find this number's greatest common factor so we can know this number's common factors. Okay, 2 raised to the power of 3 and 2 squared, smaller is 2 squared. Okay, these are the same number, so we just need to get 5. 2 squared is 4, so 4 times 5, the answer is 20. So 20 is the GCF of these two numbers. Now that we know the GCF, we can now find the common factors of these numbers. So what are the factors of 20? So we have 1 and 20. 2 and 10 are also factors of 20. With 4 and 5. So 1, 2, 4, 5, 10, and 20. These are the factors of 20. And these are the common factors of these numbers. So among these options, 15 is not a common factor of these two numbers. Let's move on to the next problem. GCF of two numbers, 2 raised to the power of 4 times 3 squared times 7, and 2 raised to the power of a times 3 times 5 is 2 squared times b. The question is, what is the value of the natural numbers a and b? So this problem is asking for the value of a and b. Okay, so let's get 2 raised to the power of 4 times 3 squared, okay, times 7. Okay, next is 2 raised to the power of a times 3 times 5 times 5. Okay, so the GCF of these two numbers is 2 raised to the power of 2 or 2 squared times B. So we are looking for the value of A and B. Okay, it means the value of A here is 2 because it means that 2 squared is smaller than 2 raised to the power of 4. So A is equal to 2. Okay, how about here, B? Okay, it means B is 3 because 3 is smaller than 3 squared. So B is 3. So A plus B, so 2 plus 3, the answer is 5. Okay, let's answer the last problem. How many common factors do the three numbers 2 squared times 3 raised to the power of 3 times 7, 2 times 3 squared times 7 squared, and 3 squared times 5 times 7 raised to the power of 3 have? So this problem is asking for how many common factors. The first number is 2 squared times 3 raised to the power of 3, okay, times 7. The second number is 2 times 3 squared, okay, times 7 squared. And the third number is, okay, 3 squared times 5 times 7 raised to the power of 3. Okay, we need to find these numbers, okay, greatest common factor. Okay, so 3 raised to the power of 3, 3 squared, and 3 squared, these are the numbers that have the same base. Okay, 7 squared, and 7 raised to the power of 3, these are also the numbers that have the same base. So among these numbers, 3 squared is the smallest. And among these numbers, 7 is the smallest. 3 squared is 9, so 9 times 7, the answer is 63. It means this number's GCF is 63. But this problem is not asking for the GCF. It's asking for how many common factors. So 3 squared has how many factors? The exponent plus 1. So exponent is 2 plus 1. So it's 3. How about 7? Exponent is 1. Okay, plus 1. So there are 2 factors. So 3, okay, times 2, the answer is 6. So these numbers have 6 common factors.